Ladies and gentlemen, I request you all to please be seated and put your phone on silent mode as we are about to begin the session. In the interim, I'm pleased to announce that we have set up our exhibition, Nirman, at the Charminar area, which is an innovative showcase presenting sustainable alternatives within the construction industry. To promote awareness and engagement on sustainable habitat, Griha Council has initiated the Griha Green Building Tour series across India. The tour have showcased exemplary projects like Income Tax Department Bhopal, Vastukar Design Studio Bhubaneswar, Net Zero Carbon Homes Mohali, and ABB Bangalore campus, and many more. The Green Building Tour of the prestigious Uttarakhand Niwas, which is also a Griha 5-star rated building, was conducted on 1st November as a prelude to the Griha Summit and received an overwhelming response from the participant. Another major attraction is the BIPV model by Future Urban Technologies Private Limited that demonstrate how solar panel can be aesthetically and functionally integrated with the building facade to generate renewable energy. In case any social media updates are shared, please tag us and use the hashtag Griha for all and hashtag Griha Summit. Once again, good afternoon, everybody. I am Prachi Pandey. I am delighted to welcome you all to the thematic session 2 of the 17th Griha Summit, Extraction to Execution, Innovation in Building Materials. From quarries to construction sites, building materials shape our climate future. As the demand for the infrastructure grows, so does the urgency to decarbonize every stage of construction, value chain from raw material extractions to final execution. This session will highlight the advancements in sustainable building materials and technologies that reduce environmental impact while maintaining structural integrity and performance. The session will delve into the innovation in sustainable building material industry and supply chain strategies, empowering construction industry to become a catalyst for sustainable low carbon future. Now I would like to introduce the session to everybody. Our esteemed chair for this session is, ma'am, I request you to please come on the dais, Architect Chitra Vishwanath, Principal Architect and Managing Director, Biome Environmental Solution Private Limited, a Bangalore-based firm known for ecological architecture and water-based focused design. With over 3 decades of experience, she has led pioneering work in sustainable schools and community spaces designs, while actively mentoring design education and serving a prestigious international architecture juries, including RIBA Asian Pacific Award 2025. We welcome you, ma'am. A big round of applause for ma'am. Now I would like to introduce to the panel Mr. Kaustubh Phadke, India Head, Global Cement Concrete Association, India. Sir, can we have you please on the stage? Thank you. Welcome, sir. Ms. Yevgenia Pozygin, Senior Associate Zaha Hadid Architect. Ms. Millie Jain, Founder Monk Spaces. Mr. Subramaniam N.E., Managing Director, Saint Gobain. Mr. Tarun Jami, Founder Green Jams. And Dr. Gyanesh Gupta, Senior Manager, Development Alternatives. A big round of applause for the panel. So just before we begin the session, I would request ma'am and the panelists to kindly have a small group photograph here on the stage. Now I would request the chair to lead the thought-provoking section. Over to you, ma'am.
So I must confess, this is the first time I'm doing this, being a chair. I've been always in the panels. So we all know that 40% of global greenhouse gas emissions come from the built environment, and here are all the culprits. But at the same time, developing countries and emerging economies like India, we have to build, especially in order to improve our HDI. So this puts us in a difficult position, especially in South Asia, where we face the harshest impacts of climate change while still needing to use large amount of resources to develop. So let's take steel, for example, a material essential to our daily lives. The present good health we enjoy, a lot of it is because of steel, glass, cement, whom we otherwise call villains. So India needs steel in huge quantities, yet we continue to export much of the iron ore we extract. So this means that while our people and our forests bear the cost of extraction, we do not fully benefit from the resources we take from our land. We are caught in a bind. We suffer from the impacts of both extraction and construction, yet do not use the resources we all have, and also wisely. This is why we must reflect and innovate to design more sensibly, improve performance, and develop new materials and systems. We also need people who can guide us, both manufacturers and users, towards better and more sustainable choices. Today we are fortunate to have with us 6 inspiring individuals who have dedicated their work to finding innovative solutions that lead us towards a low carbon and a secure future. First we have Tarun Jami, who is turning agriculture waste into carbon negative building materials, challenging our definition of a resource itself. Then we have Millie Jain from Monk Spaces, a consultant shaping the very standards and framework that will allow us to measure and trust the environmental claims of the new materials. Mr. Subramaniam represents a global manufacturer, Saint Gobain, that is driving innovations in high-performance, energy-saving materials at large scales. Joining them is Gyanesh Gupta, a sustainability and energy efficiency expert whose work focuses on building decarbonization and net zero pathways at DA Development Alternatives. And Mr. Kaustubh Phadke, who brings over 2 decades of experience in environmental engineering, sustainability, and circular economy from Global Cement Concrete Association, India. And finally, we have an architect from Zaha Hadid Architects, Ms. Pojigan from Shenzhen. She's coming from Shenzhen, and she will be presenting the works of the office, and that will be at the end of, after we have discussed with the other 5 people, and who we all know about the architect office and their work, and we will see them in a context. In the context is that I've just divided the whole session into 4 segments, and they are carbon, performance, adoption, and cross-sector impact. So the questions would be in these stages, okay? So to begin with is carbon. So each person would reply to the question, and we go to the next segment. Yuvnika will be summarizing ZHA's work in these 4 segments as a presentation in the end. So, Tarun, let's begin with the performance part. Beyond being carbon negative, how does Agrocrete, that's the name of the product which is working on, and many an architect, including us, are aware of it, compared to traditional concrete in terms of compressive strength, moisture resistance, and durability over 75 years of a lifetime? Because that's what the concrete guys, the cement concrete guys will compare with, okay? So what are the key parameters you're focusing on for future product improvement?
Yeah, well, I'll just talk about the existing product that we have and that we've been putting out in the market. We've done about 20 projects so far with Agrocrete. And primarily, I think the adoption curve has been, it's been quite favorable primarily because we're able to offer the same performance from a mechanical performance, structural durability, and so on as compared to conventional concrete blocks, but with the added advantages of being carbon negative, not using any cement, and having 3.5 times more thermal insulation, which again results in a 60% reduction in the energy consumption of a building. There have been buildings that we made which don't need, actually homes that don't need air conditioning in a place like Vizag. Offices, again, close to Vizag, which consume 60% lesser energy. So overall, like from a, the oldest building that we have is about 5 years old now, built entirely in load-bearing masonry. Albeit it is just one story, but still from the foundation all the way to the top with a solid RCC roof on top, has survived actually 2 minor earthquakes. It's in Roorkee in the foothills of the Himalayas, and always like constant flooding all the time. So I think overall we've engineered the material to have the same properties as cement concrete.
Yeah, but that's through the additives, and the product is also agri-based. So
Correct, yeah.
Of
yeah.
that, in terms of the carbon.
Sure. So again, the Agrocrete is majorly made using 3 raw materials. The first one are the agricultural fibers. The second are fillers that come from various industrial streams. And third is the cement alternative called binder that we have developed. It's an alkali activated material. So the key innovation that we did was improve the compatibility between biomass. So traditional cement and biomass are not compatible. So the key innovation lied in creating a binder that is compatible with biomass like agricultural fibers and residues. So that was the first and the most important piece of innovation that happened in the company before we went to market. What's essentially happening because of this process is when you put agricultural fibers into Agrocrete, and then the binder that we have essentially mineralizes the crop residues, you about 30 days later, once the product is made and you look at it through a microscope, all the agricultural fibers essentially turn to stone, so through the process of mineralization. What this also means that you don't have any of the durability compromises that come from using biomass that normally everyone would associate with. But second, also this results in a permanent capture of carbon dioxide. Again, might sound like, I smoked something, but in fact, this has been happening. This is something that we see that we've seen in the past. Fossils essentially happen through the same process. Vegetal concretes have been in use in the Ajanta and Ellora caves, for example, and you have several examples across the country, across the world in parts of Europe, America, and so on. What we've done is we've modernized it and made it a little bit more standardized.
Yeah. Now coming to Millie, while reducing carbon is crucial, what other environmental impact in the material extraction and manufacturing process should the building industry be paying more attention to?
Okay. So yes, carbon is most important. It's also the one that we tangibly feel the most because we feel climate change. Carbon is essentially a metric that measures climate change. But apart from this, water is a big one, water deprivation potential, which includes not just how much water you use, but how you dispose of the water that you use. Water is a big one. Use of secondary materials, SM is an indicator, which is a big one, which would in fact be very good for materials like where you have agri fiber, which is a secondary material, and non-virgin resource that we're using. Secondary materials similarly have also secondary fuels. So old rubber tires are burned in a lot of factories now. So things like that get modified to secondary. So at the construction, at the manufacturing stage, I think these four would be the key ones.
Yeah, so that brings us to you, Mr. Subramaniam. So could you elaborate on your strategies for sourcing raw materials and how are you integrating circular economy principles in your product?
Thank you, Chitra. So so I'm the only major manufacturer sitting out here, so I know I'm the biggest villain of the piece, like you rightly said. So we've been around for 360 years, so we've been the villain for a long, long time. In that sense, Saint-Gobain is a 360-year-old company, for those who don't know. So when you look at materials, how do we choose what materials we manufacture and what do we give? That's the fundamental question before we even look at the carbon and other things. Because what is that material supposed to deliver? Sustainability is has to be there in everything we do. Whatever we do, whether we go to work, the transport we use, or the materials we make, everything has to be sustainable. But what is this material supposed to deliver? And that comes back to what you started with. You said India needs to build a lot. There is no escaping from the fact that we have a huge shortage of housing. Different people will have different numbers. And we need to build fast, because you can't keep having shortage forever. If you keep employing the same methods with which we've been building for such a long time, you won't be able to. And again, coming to something you said, we have a lot of iron ore. We are exporting it. Why are we not using steel construction in India in a big way? So if you start thinking about it, what India needs today is materials which enable light construction, because you need to build fast, you need to build taller, and along with it, it has to be sustainable. So that's the core philosophy at which we at Saint-Gobain are evolving. Again, we are not what we were 360 years back. Maybe 360 years back, if you had asked us, this was not the way we thought. But we have to evolve with the times. That's the need of the market today, and that's what we would want it. Now the second question is, what do these materials need to deliver? So they need to deliver better performance. So if you look at the role of buildings, buildings primarily occupy people. All of us are residents. 90% of time people spend indoors in a building, whatever be the building, be it a home, be it an office, be it an auditorium like this, an entertainment complex. What do you need in these buildings? All of us seek comfort. That's the fundamental thing which comes from it. There are those five senses which gives us those comforts. The only comfort which no building material probably can give is taste. But the other four comforts, acoustics, your ears need to be comfortable, your nose needs to be comfortable, indoor air quality, thermal, energy efficiency, or touch. So you're looking at visual, the eyes. So fundamentally, the way we look at building materials is, can these building materials deliver comfort? And that's how it comes. And then you go back to coming back to your question on carbon and how we look at it. I think many ways, and I agree with Millie, I think you don't need to look at it just as carbon. Carbon is one thing, so how are we looking at carbon? Because energy is one of the biggest sources of manufacturing any building material. So energy is an important part of manufacturing any kind of building material, any manufacturing process, there's a lot of energy. So energy is moving away from fossil fuels, traditional forms, to more renewable forms of energy, while solar and wind are the more popular ones. What is very, very apt in India is a big agricultural waste economy. So Millie spoke about it. There is a lot of agriculture waste, and that can be converted into energy. Today, in India, we make two products which are made from biofuel, maybe rice husk, cashew kernels, whatever you call it. In Vizag, we have a plant which makes the first net zero plasterboard with biofuel. In Chennai, we have a plant which makes
You're able
net
to
zero
concise,
plaster with this.
Subramanian.
So energy, carbon is possible with these kind of things.
Yeah, well, are you employing it in your?
Yes,
thing?
these are actual live examples of low carbon energy
In your facilities.
in our manufacturing facilities.
Mr. Gupta, with India pursuing ambitions of net zero targets, what strategies or technologies do you consider most crucial for accelerating the decarbonization of building sector in India?
I think I think we have all established that it's an embodied energy and the operational energy, and both of them are of 50-50% to contribute in the emissions of carbon. Uh, the technologies or the embodied carbon that we are contributing to can be addressed by materials, can be addressed by design, and policy, space, policy, advocacy, and all. Material specifically, recently we have done an analysis for the state of Odisha, in which we have come across that by 2070, the floor area that the Odisha will have from residential and commercial buildings are above 1.15 billion meter square of floor area, and the carbon that are associated with the floor area is humongous. And we have seen by the alternative materials, specifically replacing the cement OPC with the PPC or PSC or LC3, which is going about right now, that 50% of the embodied energy can be mitigated or reduced by replacing of materials. Design aspects is also come in the way, because structural design, reduction of beams, wall masonries. Even a simple example of when you do a wall masonry, the plaster that you do on the wall must not be of the same composition that you are building, the other walls and all. It can have small cement in the composition of concrete and all. So these are some of the things that can be altered, and the embodied energy can be reduced. But even if I say that 50% or 51% of the embodied energy or the energy can be reduced, you need to go for other means also, like agro or alkali based binders in cement or in fly ash bricks. And for the last part of it, you need to go for the energy like renewables to make it purely zero. So I think these 3-4 strategies needs to be integrated.
So Mr. Fatke, how do you see cement sector progressing toward the net zero goal in terms of manufacturing and other stuffs? Now we have GPC and other concretes and other
Yes,
cements coming.
So in terms of cement sector, how progressing, we have made a roadmap to be a net zero CO2 by 2070 at the cement level, and this is in alignment with Government of India's net zero target. But there are other levers mentioned. By the important lever is supplementary cementitious material. So you replace the clinker, which is the actual CO2 contributing material. You replace with a fly ash, which is industrial waste, or a GGBS from the steel industry, or now new cement, which is calcined clay cement LC3. So that's supplementary cementitious material substituting the clinker is the one of the important lever which is being implemented in India, but there's a huge opportunity to further increase the SCM use. Second is the cement sector sits at the center of, you can say, as a solution provider in circular economy. Any material can be used in cement manufacturing provided it has some calorific value. So on a lighter note, we say the cement is a scavenger industry. So you put any material, municipal solid waste, it can be used. Industrial waste, it can be used in manufacturing. So it is called as alternative fuel. It's actually it should be the waste management. So alternative fuel potential is huge, because that will replace the coal and pet coke, which is used in the cement manufacturing, because the temperature required is around 1400 to 1500 degrees Celsius, which again contributes to CO2. So So replace coal and pet coke with alternative fuel. That's the second, we can say, important lever. Third important lever is, as everyone knows, the energy efficiency. The Bureau of Energy Efficiency has now given a target for the cement industries to reduce the intensity. So energy efficiency has been driven very significantly, and it also has a huge potential. And the fourth one, which is always been talked a lot about, is the CCUS. So carbon capture, utilization, storage. Being a hard to abate sector, the CCUS is the only one which can help us to reach a net zero. And there are other levers, like somebody talks about the nature as carbon sequestration, use of nature as a service. But all these levers we need to look at from the size of the cement industry, because India, is the second largest cement producer in the world. We manufacture around almost 450 million tons of cement every year, and that's we consume. But the per person consumption is much less because of our demographic size. At the same time, cement is the cheapest manufactured material available on this earth. You tell me any other material which is sold at 7 rupees a kg. Any manufactured material, even the packaged drinking water we pay 20 rupees a liter. So it's a huge material which is required. Without cement, you can't see any infrastructure. Even 2070, we want to be or 2047, we want to be a Vikasit Bharat. And when we'll be net zero by 2070, the infrastructure which is required to be a net zero is not yet been built. So the first and foremost important point is to make the cement and a concrete industry a decarbonized industry, which will actually truly will make the India as a net zero. So if you want to reach India for a net zero at 2070, the cement and concrete must be net zero by that time.
Yeah, but we also have to worry about whether we'll have enough limes for making stone, in making cement itself. Thank you all. Much of it, whether it's carbon, and I think the next one was performance, but you people have brought the two together. But I still have the questions, and then slightly different from what you spoke. So Tarun, getting back to you, you think that the future of building is all bio-based. So what do you imagine a fully realized bio-based construction ecosystem to be like?
I mean, that's the hope.
Yeah.
In
But let's
ideal
talk
scenario,
about
it has to
over
be
here,
bio-based, but
yeah.
again, I think if we were to be realistic, I don't think that's ever going to be possible. I think it's essentially going to be a mix of both bio-based as well as non-bio-based solutions, which have already been heavily decarbonized and so on and so
it's
forth.
a balance. Yeah.
Correct. It definitely has to be a balance. Sorry, the question was, how do we achieve it? Or
No. What do you see it as a future of bio-based ecosystem completely?
For sure.
What
So-
do you
It's
paint a picture?
Such a difficult question, really.
Yeah.
Again, so that's essentially what I was trying to explain. That we have a balance of both of these things happening. Bio-based is, again, tremendously important because one, I'm sorry, I already have the questions that you're going to ask me, so I'm going to jump into the next one a little bit. The reason bio-based is important because, like for example, when you look at agriculture or agroforestry, construction is the second largest employer in the country, but agriculture is still the first largest employer in the country. But when you have an opportunity to marry the both and create value for both sectors at the same time, is when you're able to deliver significant impact in terms of course, economic development, but also social development and the other aspects that come along with it. So, well, there would definitely be some portion of it. I think if you were to look at the total built-up area that we'll have in the next 10, 20 years, ideally at least 25% of it should be bio-based. in different forms. Of course, bio-based cannot replace concrete entirely, because it still is the cheapest and the strongest material that we have and the most easily scalable. However, I do think that clinker needs to be 100% eliminated. I think that's the first lever that we pull, and then building on it, then we start expanding the amount of bio-based materials that we essentially put into it. Of course, that would essentially also mean that there's a significantly higher amount of R&D that needs to be done, a significantly higher amount of adoption, like levers that would include policy, governance, and so on, that will have to be, and incentives to be put in place. Only then will we be able to achieve this.
So, Mili, I'm coming back to the global south, and I'm asking you the question when you are talking about the PCRs, product category rules. What were you able to incorporate when you were in the global summit, and what do you bring from us?
Right. So to give you some context on the question, so all LCS for construction materials are done by this reference document. So the rules come from a document called PCR 2019-14, and the PCR went through a major revision starting last August till this March, and there were 4 companies who essentially helped revise those. There were 2 companies from Europe, 1 from New Zealand, and there was 1 from us, 1 from India, which was us. So essentially, when we were in the room, what happened is they base everything on studies that are done. So unfortunately, what happens is all the studies that are done are based in the European context. So all the default values become European. They are not representative of our industries, which are more labor intensive, less energy dependent in that sense. So a lot of the things, yes, we have a lot of mechanization, but compared to the Europe, we are still very labor dependent as a manufacturing industry. So what we really push for is whenever they had like a default, okay, this is the default value that we want to tell, we made sure that you put caveats. Okay, if we are doing this study for a manufacturer in India, if the manufacturer has reliable reference point for this, we will use this value from the reference point rather than the default that Europe suggests. So what happens when we are able to do that is that our numbers typically become lower than the European manufacturers. And of course, not just that, it's not just good that they're lower, they're also more accurate that way. They are more representative of our manufacturing.
Yeah, and our scene in terms of population. And
exactly. So we were able to push for those and make that happen.
Thank you. So again, getting back to you, Mr. Subramaniam, is that while she looked at global, I'm asking you what your products in terms of the diverse climatic zones in India and the typologies, the performance. Obviously, let's talk about glass itself, but different zones.
So I think that's interesting what Millie also said, that most of the studies, most of the codes all come primarily from Europe, the US, which are fundamentally more colder climates.
Yeah.
While India is hot and humid, so very different. And that's the adaptation we need to do when we bring in. As a global manufacturer, it's the easiest thing for us is bring a product which we make in Europe and sell it in India. But that's not what we try and do. So we have actually set up an R&D facility in India, which is the global center for developing products for hot and humid climates.
And that's in Chennai.
In Chennai, in SGR.
Yeah, that's very important to know.
Yeah, it's in Chennai, co-located in the IIT Madras Research Park. So it's one of its kind, and we develop products for the hot and humid. So we need to adapt products. I think there was a session just before this where someone else was speaking. You can't just cut, paste, and copy everything, whatever we do. Typically, that's a cultural thing for us. But I think we need to adapt to this requirement. So the comforts don't change, but how we use the materials, how we design materials becomes important. And that's fundamentally what is driving us at Saint-Gobain in terms of how do we adapt to this needs of climate resilience. So what is the needs in India? What is the climatic conditions? Especially moisture is a big thing in India again. So most of our products, most people will ask you about water What is the water? How much moisture does this absorb in an Indian context is a big thing in India. So these are things which we keep in mind as we design products, be it glass, be it gypsum, be it construction chemicals, be it insulation. We make a variety of products, but all of these are adapted to the hot and humid kind of climatic condition.
So, Mr. Gupta, about energy modeling and performance simulations, which are the tools which should be integrated early in the design process to achieve measurable reduction in operational energy?
I think right now, what happens is in 99% of the cases, when the simulation has been done after the building has been constructed or midway, or when the developer wants some pre-occupancy certificate or something of pre-certification kind of thing, then they come to the simulation part. But I think the simulation needs to be done on the design stage only, when the designs have been, because you have done half the damage when you have constructed the building without even consulting or without even looking at the simulation, that what's the AO flow, what's the design flow, what material that can be used, sourcing locally also, because simulation gives you many aspects of going from material to operational energy to your AC or the HVAC that you can use in your building. And many of my colleagues said this, that the building has already been constructed, we cannot do something on a design space. Now we are to focus on the interior part or the operational part also only. Sir, please lightning, do some sensor lightning or do some on the windows, double glazed window or anything, but you can't do anything with the design. So your 20-25% of what can be achieved in your designs is already been gone. So 100% net zero is not like, it's forget in the building. And some of my work in the benchmarking that we have done previously, those can also be linked to the codes, moving from what I can say, the moving to performance-based codes, yeah, that for some of the performance that you have met, your some incentive or something of that kind can be given to developer and all. In some cases, some incentives are already been defined, but yes, more on that front can be done.
Yeah, I think when we see Ms. Poshkin's presentation, I hope we would see how they envisage a design and how it performs. I think that will be very clear in this. And Mr. Fatke, about use of blended and low clinker cement. How is it being promoted as sustainable alternatives, and what steps are you taking to ensure that these materials meet the durability and performance expectations?
Okay, I'll give you one example for this blended cement, because as you mentioned, the reducing the clinker factor, even my fellow panelists say that his dream is to be cement without a clinker, which I hope will not come to see the light of the day. So because I'm from the cement industry. But jokes apart, one example how it is being done. So LC3 cement, limestone calcined clay cement. So we have an entity called as the BIS, Bureau of Indian Standard, and only the BIS certified products are allowed to sell and use in the Indian market. So for a cement, so LC3 work actually started somewhere in 2000, I think 11, 12, when actually people thought about calcining the clay and using it as a clinker substitute and manufacture a cement. So in 2011 or 13, the work actually started. The work happened, the study continued for the last 12 years, and the standard on LC3 saw the light of the day in 2023. Almost 10 to 11 years work happened for a cement to be certified by the BIS. So there is a very robust process deployed by the BIS, and not only the manufacturer, but also the end users tested that cement. When they felt that there is a durability, it meets the criteria, because most important standard which we need to meet is IS 456, which is for the concrete. So when the LC3 was able to meet the requirement, the performance parameter, then only the BIS agreed to come out with the standard, because then it was allowed to be manufactured. So there's a robust mechanism. We have an entity like BIS. You cannot say that I made a cement which is a 40% lower clinker or 40% lower CO2, let's start using it. No, it can't happen. It has to be follow a structured process, a comprehensive review happens, which is also peer reviewed by 2-3 agencies, and then you come out with the cement. So the durability, the workability, the quality parameters, all are taken into consideration before any standards see the light of the day.
But we're not really putting it into which part of the building could this
Yeah.
be. You could also
Yes.
specify
So
later in
IS,
terms of
IS 456 is more for the structural component,
structure.
which is the most important element. There are other cement which are approved by BIS, but for the non-structural applications. So the BIS has kind of even bifurcated. They are not saying not to use, but it has to meet the durability parameters for a structural element. And non-structural, there are other materials which are being done. Like there are, we have one stall where the CND waste is used as a substitute for the, you can say the clay bricks. But that's a non-structural component, so which they are allowed to use it after meeting certain criteria. So there is a process available even when you manufacture any material and we want to claim to be a low carbon material, it has to get a BIS certification.
Thank you everybody. So I'm kind of concluding here and asking Ms. Evgenia Pozhigan to do a presentation which would probably encapsulate most of these questions. Thank you.
Thank you very much. I think you will see. I can click. Okay, great. Thank you. Good afternoon, everyone, and thank you very much for giving me this kind of a special place in this session. Thank you, Madam Chair and fellow panelists. It has been very interesting to hear the insights from the Indian market specifically, because while we work globally, in India we have relatively small amount of work, so it's important for us to also understand how it works on the kind of on the local level. And while I wanted to contribute to every part, I think we are very visual people as architects, so I prepared a small presentation. And to cover the four very important topics in 5 to 7 minutes is difficult. Please stop me. So we discussed very importantly the carbon, the performance, adoption, as well as cross-sector collaboration. So, so in our work, so we are multidisciplinary practice, and we work with the science-driven design. We have a sustainability group. We have different groups in the office. So one of them is a sustainability group that is involved from the early point, from the concept design. And we have a group dedicated also to working on the strategies towards net zero. And while working with the clients, it's important to understand for ourselves and to explain what is the initial carbon investment and the long-term carbon strategy. So at the early stages, we work with the digital twins, and very rightly, as Mr. Gupta just said just before, we work to analyze and to kind of to project what is this the carbon impact would be, and we work with the so-called life cycle assessment databases through the early stages, assessing and optimizing the structural, architectural solutions, planning solutions, as well as also analyzing all the kind of the environmental parameters of the building, which allows us to kind of to adapt the design in the real time, not really changing it. And it's kind of, it's a holistic approach which we try to implement on every one of our projects. And then now it comes, of course, to the kind of to the adoption and the cross sector collaboration, because we are definitely not alone. For this to work, for sure there needs to be a client that is willing. There needs to be kind of the technology in the given country. There needs to be regulations that are already existing or are available for this kind of for these strategies to be implemented in the real projects. I'm going to show only 2 projects. I tried to cover the questions which we discussed before, and what we do, for example, in this is the BA headquarters, is the headquarters for the waste management company, and this one achieved the LEED Platinum, and this is close to net zero building. So what are the parameters that we as architects and clients try to achieve here? It is a lifespan of the building and operational efficiency, and as well as material efficiency, as well as responding to the specific climate conditions, which has been also touched upon here. So in this building, it's kind of all combined. So the form of the building is responding to the kind of to the sun orientation and the direction of the wind to maximize the environmental comfort through the passive strategies, as well as optimized shape. So for us, especially for us at Zaha Hadid Architects, it has been a challenge through many years, and it is still now. How do we make our shape work, as well as making it actually more sustainable and making it more efficient? As well as introducing these strategies. So this example of the project where we actually almost kind of managed to achieve this. So the key net zero strategies were using the exterior lightweight GRC panels, energy generation and management, which is very important for this building as well as for any building. And this is something which comes from regulation and comes from the strategy on the city level or the country level. For example, coming now from Shenzhen, almost 70,000 buildings are equipped with energy management systems, just simple buildings, monitoring as well as managing the energy from the communal area, for example, lights to the lifts operation and so forth, which actually allows on the city level to reduce the energy. When we come back to this building, here this is done also through the advanced AI supported energy management systems in the building, which helps to save the energy, or like to actually make it very energy efficient. So when we move on, also kind of about a little bit touch base on the model methods of construction, and this comes to the cross-sector collaboration and adoption. So the off-site manufacturing, which is a very important point in the locations, because we work around the world, and in different locations, the availability of different materials and readiness to produce the building components is different. So first we start, of course, by trying to use the materials that are locally available and locally used. For example, it can be brick or timber. And then it comes to the capacity, production capacity, how we can manufacture it in a more controlled way. So off-site fabrication or modular construction, it could be an answer to that. And while we say modular, it doesn't mean it needs to be the same everywhere. If we talk about residential construction and increasing the housing stock across the country, these modules and components can be different and locally adapted to the local, also importantly, cultural aspects. And something that is not touched upon in this specific project, but what we try to do is also the community engagement, where the community can actually be participating in the decision making, which is difficult in many cases, but again, with the modern technologies as well as like AI and gamification, it is possible. Again, touching base here on something that is a little bit far from the topic, but also kind of related to everything that has been discussed today. Of course, so the material and circularity. We talked a lot about different material components and what we try to do through research, starting from from maybe smaller forms or research projects in our research laboratory that is over 20 years, researching the geometry and structure and fabrication methods. And it's been, over 25 years. Through small structures, through pavilions, it's a work and in collaboration with many other industries to test new construction and fabrication methods to then apply to larger scale projects. So we have our technology lab. This is our in-house in our office in London, where we can do the kind of the testing and prototyping, as well as building small forms with this robotic arm, which then we try to actually also use in the larger scale projects. So those are kind of the structures and methods that we explored over the years. Through, of course, the 3D printing is one of the main ones that we've been trying to push forward, and as well as the digital timber bending and joinery, and again the 3D printing of different materials. So this project is a small project of a bridge that has been done with the Block Research Group and ETH Zurich, where I think all these kind of ideas of reduce, reuse, and recycle come together. I just wanted to show you a small video. So this was done for the Venice Biennale, and this bridge is made of 3D printed blocks that are kind of joined, attached together. And here we researched about kind of the structure, what is the optimal structure for the 3D printing. The whole team designed the concrete mix that has been used for these 3D printing blocks. The optimization of the structure and all the kind of the design components have been done, designed by us in-house in collaboration. And the bridge has been installed for the Biennale. It is kind of a relatively small project, but for us it's a big step forward how we can use this technology in the future. This bridge later on, it has, because it's also a research project, and how we can make it better next time. And how we can reuse this, because it's been done for the Biennale and then has to be demolished, so something that is not permanent, but what can we do with it later on, and how we can learn from the, not mistakes, but let's say what we can learn from it to do something different. So the Stratus Bridge became a Phoenix Bridge. So the concrete has been crushed and then reused and reprinted in a more optimized form, and installed in a different location in Lyon, in France. So it's been kind of evolution from one project to the next. So the one on the top is the original bridge, and then below is the kind of a new bridge, adapted also to the specific site conditions. So one was done in 2021, and then disassembled, kind of remanufactured in different form with also smaller building, what I showed now, the last one. But it's kind of the process that we are trying to use as an architects. What we can do in-house is, and with other collaborators, to really push the industry. And this kind of working with the industry and capacity building in many different places. For example, in China, we work for over 20 years, and there we worked with concrete manufacturers, as I said, GRC manufacturers, to create special mix and special production that would allow to kind of to create some of our projects, as well as with glass manufacturers to actually achieve the performance, keeping the design. So for us, it's been both the challenge of the design integrity and the challenge of always challenging the industry and the production, but also kind of with all of that, trying to really work towards the sustainability targets in many different places. And that, again, it comes to regulations and the industry readiness in different countries. And sometimes, of course, it is challenging. But through, for example, what can we do as architects? Through our internal research, we try to bring it to the next step and make it industry ready. So yeah, I guess I stop here.
Thank you. Questions from the audience, or we have finished the time?
No, we will ask.
Okay.
Thank you to all the speakers for their valuable insights. Now we open the floor for questions. Kindly raise your hand before putting up a question, and a mic will be brought to you. And also kindly introduce yourself before asking the question.
Sir, my name is Abhinav. I'm from Interglobe. And my question is to the gentleman from Saint Gobain. Sir, you mentioned about the Indian climate, hot and humid, and Saint Gobain is particularly doing some research and innovations in terms of adapting to the hot and humid conditions, the manufacturing. So I would want to know, sir, in India we have different climates already. We go to Ladakh, we go to Montserrat, or we go to Rajasthan, we have hot and humid and very cold places. I think, as per my knowledge, sir, Saint Gobain is manufacturing similar kind of product distributed into India. Not like certain material supplied to Ladakh region, certain material supplied to Montserrat, like Cherrapunji and all, and certain material supplied to Rajasthan or Gujarat, where desert and very hot conditions are there. As far as I know, you have glass, you have gypsum, you have now silicon also, I guess, if I'm not wrong. So silicon, if we use 3M, we use Dow Corning 7 at 9, we have used widely used products in our facades. What specific Saint Gobain is doing in terms of hot and humid conditions and very cold conditions of India, which is not there in Europe or not copying from Europe? Similar question goes to gypsum and the glass.
You seem to have one thing I must commend you is you know a lot about Saint Gobain. So one is on silicon, I don't think we do anything on silicon. So just to clarify, there's nothing on silicon. We do construction chemicals a lot. Fosroc is a Saint Gobain company now, just for your information. So there is, of course, gypsum insulation. So again, like I said earlier, the material base is the same. So glass is glass. It's not going to change its character. But the kind of glass you use in a Ladakh will vary from where you use it. And again, the usage of glass in a facade will also vary. So depending on the heat, and I think the architects are best positioned to where to use glass to maximize visual comfort as well as reducing the harshness of the elements. So basically, if you look at what we are trying to do in India is there is materials, but what we are trying to do is see what we can add or subtract from the materials to make it more adaptable to hot and humid. When I mention hot and humid, it's not generalizing the climate across the country, but that's the core of a lot of our weather areas and where it is different from what it is in Europe. When I didn't mean Ladakh is hot and humid, definitely not. It is very much a part of India. So, but my generalization was more to do with the large parts of India are fundamentally hot and humid, which is very different from what you would have in a Western Europe, for example. And that's the generalization I said. So again, if you look at building materials and if you look at the way we build today, there is a lot of need for comfort. Even today, if you were sitting down in the hall below, you would notice that there's a lot of noise coming from outside. Are we protecting ourselves? So when I say comfort, we have to start building. And again, materials like insulation are extremely important, and that can really change the way we do our buildings. So today, we're talking of a lot of energy efficiency in buildings. But energy efficiency, one is the embodied, but we're still talking air conditioning. Are we going to change the way we use air conditioning? No. Hot and humid means we'll need a lot of air conditioning because the weather patterns are like that beyond a point, we all need a lot of air conditioning. Do you have air conditioning in your homes? I'm sure all of you have. But how can you reduce the need for air conditioning? If you use insulation smartly. So if you insulate your walls, you insulate your ceilings much more smartly, your need for air conditioning will come down dramatically because your natural temperature which you keep inside will come down considerably. The need when you switch on the AC will be determined by that. So those are small tweaks. And similarly on materials, we are doing a lot of R&D, innovation in this area, wherein we are making small tweaks to make those changes happen. So no specific answers. Of course, we can catch up separately, my team, and explain to you more in detail on these.
Hi, this is Ramneek from Habitat India. Our question is to Ms. Posigan. Thanks for the wonderful presentation. So it's a two-part question. First is that the construction industry or the real estate industry is a legacy industry. So traditional methods, traditional vendors, traditional materials continue to be in place. So how is it that in India, when we are going vertical, especially the urban transition in India, how do we make the real estate developers transition to looking at new materials? And second is that your global experience in terms of how amenable are your global clients to look at new materials, because a building is made for the next 60, 70 years. So that's the challenge which we see in our interaction with a lot of large developers.
Thank you for the question, and it's definitely a challenge everywhere, almost everywhere we go. I think for us, China has been a good example because there has been so much work done in 20 years, but it has been extremely challenging, the kind of the transition. So the industry, it's not only about us, how the industry adapts and how the benefits are seen by the developers and the long-term benefits, how they are seen and how they can incorporate the cost, the initial maybe higher cost, into the kind of the whole life cycle of the building and this model. So we work now also in much smaller places with much smaller developers. We work in challenging places like Malta, where there is almost nothing produced locally, and the local contractors did not have the experience, and the local architects did not have the experience. And that's the capacity building and kind of the knowledge transfer. And yes, it takes time, but I think it comes with the willingness of the client and seeing the kind of the potential. And another one is the regulations and the overall kind of statewide kind of implementation. The other challenging place we now work is Georgia, for example. Small country, again, small developer, but willing to invest in something that will be a kind of a legacy. So I think in this case, India has much more potential and much more kind of mature industry that can switch much faster And in the end, the materials are the same materials. It's concrete and glass and maybe timber or biodegradable materials, which is very interesting. We can talk about that. But in the end, it's how you use it and how we as architects, for example, for us, it's been a learning curve, and the establishment of this kind of research group is also to optimize our geometries, because we want our design to be to be there for 50, 70, 100 years. But we had to learn also to work with the engineers, with the manufacturers, to test through the prototypes. And for every building we do this, we go through this process of using fairly traditional techniques to achieve something that would push the boundaries.
Any more questions? Okay. So before we conclude this session, I request Chitra ma'am to kindly present a small gesture of gratitude to all our esteemed panelists here for gracing us with their presence and for their valuable insights. And you can come in front. Yes, ma'am. Thank you, ma'am. Now I request Ms. Shabnam Basi, Deputy CEO, Griha Council, to present a token of gratitude to the esteemed chair of the session. Thank you, ma'am. This brings us to the end of Thematic Track 2. On behalf of Griha Council, I would like to extend our heartfelt gratitude to our esteemed panelists and all of you who are present here. Please remember the hashtag for the event is Griha for All and hashtag Griha Summit. Please use this while posting any updates on the social media. We look forward to welcoming you all back tomorrow for the sessions and upcoming events. Have a wonderful, restful evening. See you tomorrow. Thank you so much.